Hello everyone, in this video I'm gonna be talking about linked list, but before we go dive into the coding part, let me just give you a quick description of what a linked list is. Linked list is also a data structure, and it is a collection of nodes that together form a linear ordering, in that each node is an object that stores a reference to an element and a reference called next to another node. So here I have a graphical representation of a linked list that contains 4 nodes, and each node has a pointer reference that points to the next node after it, and the first node is usually called head, and the last node is usually called tail, and the last node also points to a reference called null, meaning it doesn't have any node after it. That's why it is null. So there are three types of linked list. So the first one is singly linked list, doubly linked list, circular linked list. However, in this example, I am going to show how to implement the singly linked list, and we will do the, the doubly and circular on the next video. The practical applications of linked list is, one example of this is the queue, or implementation of queue, or the queuing system, and the stack, and also the automatic plate dispensers. So that's it for the description, and let's now go into the coding part. So Java has provided us with a default linked list which we can use to implement. So we'll call this linked list. We call our list object as list, and new linked list. So it has an error because we still need to import java.util.linklist. So here we have the list object instance, and if we push the dot operator, we are going to see a bunch of methods that are already inside the Java class file linked list. So we can add an object, we can add first, add last, we can even clear the list, and we can search using this method. We can also get the first element and the last element. So let's try to add an example how to add. So let's try John. So we are using a string here, so let's use a good coding standard practice. So put string here and also put string here. So next, add one more, we call this Smith, and add another, we will call this one as Brand. So here we have a list, linked list called list that contains strings. So we can display all the values inside our list by, oops, we have an error here, and then by passing the list here as the parameter. So let's try to see first. So here we have John, Smith, and Braun in the order as above. So suppose we wanted to have a Wesley before the John, so we just need to call our add first here, Wesley. So Wesley now is the first and not John anymore. So let's try to check, verify that one. So Wesley is in the first list and not John anymore. And suppose we wanted to add another element after Braun, so we will call the list that add last, and we will call him as Hikaru. And let's try to run again. So now Hikaru is appended after Braun. Okay, so we can also iterate through the loop and display all of the list that we have, and we can also search based on the bunch of methods that we have here. So there are a lot of methods that we can use, built-in method. However, let's try to see how to iterate through the loop, or search an element inside our list. So we will use iterator. We'll call this one as I, or iterate, or simply as it, and we will use this one method. And then using the while loop, we can say while it has next. Oops, because we have an error, we need to import iterator. Now if we push the dot operator and choose the has next, and then the brackets here, and then suppose we wanted to get brand only, so we can use the if statement and then the bracket, and then suppose while the if it has not has the next method, which equal to brand, then we are going to display some info into the screen, and then say we want to display brand has been found. If brand has been removed, then we can put an else statement here, system.out.println no element has been found. So let's try to run. No element has been found, brand has been found. So brand has been found on the fourth loop, because we add 1, 2, 3, 4. Wesley is the first, followed by John, Smith, and Brand. So John is found here, or Brand is found here. So you can experiment the other methods that have built in here, but let us now proceed by making our own implementation of a linked list. So in this, we are going to be needing a new Java class file. We will call our class file as let's say link. Let's link. Hit finish, and then we are going to create a nested class here, and we will declare it as private and static. So private static class, and we will call this one as let's say node, and then we will use the generic one. So by using these brackets, left and right brackets, so it tells the Java compiler to use the template, generic template. So you will know later the advantage of using the generics. We call this one G, so that it makes clear what is this meaning of the brackets. So we will declare a private variables here, and we will use the G as our reference, and we will call our G variable as let's say data, and then another variable here for the node, and this one is the we'll call this one as next node. So this will be, this next node here is a pointer. So this is a pointer. It will be used as a reference or it will point to the next node in the list that we will going to create later on. Now we need also the constructor called node, and then we will pass here the let's say new data, and then node g, and then pass here n, and then we will bind our variables here. Data equals new data, and next node will be equal to the n, and then after this one we are going to create a method called getter. So getter method, by the way, so we'll call this one as public g, and then we'll call this as get data, and then all it has to do is to return data. Next we need also the another getter method to get the next reference or the next link. So we call this one as node g, and then I call this one as get next link, for example, and then so inside our braces here, all it has to do is to return the next node. Okay, so next we also be needing the what's this, setter method. So it doesn't return anything, so it will be a void, and then we call this a set next link, and then we will pass here a parameter as not link, node, our node g n, and then inside here is the next node is equal to the n. So this is all we need for the nested class file inside our link class file. So this will takes care of generating our instance of nodes later on. So next we are going to declare another variable called this one will be node, and then g, and then this will be the head, and or we can initialize this one into null. By default, if you are not going to initialize this one, it will be automatically implicitly initialized as null, but it is a good practice to always initialize a variable or an instance after creating it. So we have an error, cannot find symbol. Okay, so we also need to declare our outer class file link as a generic one, and then private node g, this will be the tail, also a null, and then we also need a private variable called size. This will hold 0 for now. So this variable will track how many elements we have in our list, and after that we are also going to declare the constructor for this one called link, and this will be empty. So this is the default constructor. What's public link? What's this? Return link. Let's see what is the error here. Public link. Public. What is the error? Rename link. Okay. So I made this a small letter. So now let's proceed. So we need to declare another method to get the sizes of our list. So this will be public int get the size of our list, and then all it has to do is to return the size. Return size. Next, another method for to check if, what else do we need to check if our list is empty or not. So create a method for that. Public boolean. So because it will only return true or false. So public boolean check if list is empty, and then so this will be return size is equal to 0. So if it is empty, so size is equal to 0, and then it will return false. Okay, so next we are going to create a method that will retrieve the first element. So public g, do not forget the g, guys. The g here is the g here is used to make our methods generic, meaning it can accept not only string, integer, and so on. So we will see later on the advantage of using the generic templates. So we will call this method as get the first element, and then yeah, so get the first element, but before he will return the first element, we still need to check if the list is empty or not. Otherwise there is nothing to return if the list is empty. So if this is where we are going to use this method. If list is empty, then return null. Otherwise return head dot get get data. Yeah, so get data method here is what we have created here above. So now proceed. We also need to get the last element. So public g get the last element, and then the same method or the same implementation here. If check list if empty, so it will going to return null again. However, if it's not empty, it is going to return tail dot return tail dot, what is the error here? Identifier expected. Let's me check first. Return null, first element. Let me check what's the error. Identifier expected tail dot, maybe because I misspelled the tail, that is why. Tail dot get data. So that's it. And we also need a method to add an item to our list. So we call this public. It's not going to return anything, so this will be void, and we'll call this one as add first element. By the way guys, this is just my my own invention of names. You can name your own method whatever you want, but this one will also have a parameter, and we call this one as e, so that our head now, this will be equal to new new not link, new node. This one, new node, will be equal to new node, and then new node, and then we will pass the variable e instance here, and we will set the pointer reference as null. But this will be not bracket but parentheses, that's why we're having an error. And then so this line here will set the head based on the data that we have entered. So head now will become our first node, but we are going to check if we are going to check if we have an element already in the list, because if we have an element in the list, then we are going to append the new node into the end of the list as the tail. So if in order to check that, we are going to use the if. Remember our size variable here, this one. This one is still 0 right now, so we are going to check if size is still equal to 0. Then we will set the tail will be equal to head. So if the size of our list is still 0, meaning there's nothing inside our list, then obviously the tail will be also the head of the node. Okay, and then increment our size. So meaning if this is true, then this will be executed, and we will going to increment our size. variable. Okay, so next we also be needing another method to add or append an element into the tail of our list. So we'll call this one as public, also a void, and we call this one as add last element. And this also will have a parameter, and then so this parameter here is a generic, and then we will what we'll be doing here is node. So this will be node g will be our new node equals to new node, and then we will pass the parameter here, and then also the reference as null, because obviously if we are going to add the last element, as per our description here, the last element or the tail, the reference of the last element or the tail is null. That's why we are going to set this as null. So we have our new node here. We are also be needing to check if our list is empty. So this one, we need this one. So if our list is empty, then we will set our head node as our new node. Okay, and then if it's not empty, else, so we are going to set the tail. So meaning if it's not empty, there is an item inside, then we are going to append our new node into the tail of our list. So tail dot next node, and then we will pass our new node here. Wait, we have an error. Cannot find symbol method. Oh wait. Tail dot get data. Here, set next link. I made a mistake. And then we are going to pass this one as our tail now. And then so our tail now is equal to our new node, and then increment the size. So that's it, guys. We have how many methods? We have one, add element, last element, add first element. Then this method will get the last element, and this method will get the first element, and this method will check if the list is empty. This will return a boolean value called false or true, and this method will track the sizes of our list. So let's try to see how we can use this and how we can apply this. Let's go to our main method here, and remember our class is called link, so we copy the class link, paste it here, and then we'll create this as my new list equals new link. Okay, so let's try to see what we have. My new list. So these are the methods that we have created, guys. Add first element, add last element, check if list is empty, get the first element, get the last element, get the size of our list. So let's try to see the current size of our list. Print n. So this will be my new list that this one first. So let's see what we have. So true, meaning our list is currently empty. We'll try to check our another method, the size. So this will return true. No, not true. 0, because yeah, this one is 0 because we don't have anything in the list. Now let's try to add. This is to show. This will be that is empty, and another, this will be like this one. So let's try to add element into our my new list object here. Dot add first element, and then we call this again John, and then another, we'll copy this one, and then we call this as Smith, and then another, we call this one as Hikaru. So let's try to run first. So hopefully this will work. The size of our list will become 3, and list will become false. Yeah, so the size is 3 and the list is false now. No, the list is, the result of this instruction is false because it is not empty anymore. It has 3 elements inside our list. Let's try to see here, so that it will be clear. We can try to display all our lists by doing system.out.print, and then we will pass our my list object inside, and then run. Oops, my list, so it return a class. So let's try to my list, my new list dot get the first element. Let's try this one. Yeah, he get the first element called Hikaru. And then let's try to use another method. Get the last element, so this will return John, I think. Yeah, John. Next, get the size of our list, get the first element, get the last element. Okay, we already done. Let's try to add, no, not here. Let's try to add my new list that add last element. This will be say Wesley. Oops, we have an error. Wait, cancel. Create a method. Why? uh okay, so this is not get, but I'm making a mistake here. This should be add last element, and then this would be Wesley. So build and then run. Okay, and then system that out that my new list dot get the last element, so this will return Wesley. Yeah, okay, so these are my simple implementations of a linked list, guys. So hopefully you've learned something, and thank you for watching.